Hello, welcome again.
Hi. Good to
I'm
see you
Timothy
guys. It's been a
Aiken.
while.
Yes, yeah, it's been a while. Sorry to leave you guys hanging. We've got 20 subscribers, which is a great start, which I believe is a great start for just having 3 episodes out. But we collected you all up and left you hanging. So hopefully, you're able to see this, come back around. We are back at it. Hopefully, we can get a few more episodes out for you in the next month or so. Um, if you don't remember, I'm Timothy Aiken,
And I'm Sidani Daly.
and this is Spill the Data.
Spill the data.
So today's subject, we're going to discuss our beginnings at Lambda School. What we're going to get into actually some code this time. Um, Talk about how we've used data science already on some projects. Our first project, which came to us, I guess about 2 months, almost 2 months into our Lambda journey, being part-time students. If you were to join as a full-time, it would be the first month that you would do your first build. Um, these are called build weeks, although ours lasted for 2 weeks. But in 2 weeks' time, we had to come up with a project on our own, decide, find a data set to analyze, create some visualizations, and try to extract some meaning just from pure data frame, pure data sets. And if you don't know what data sets are, data frames are, don't worry. We're going to show you all about it. So I will
So,
start. Okay, go ahead.
yeah, and I was going to say that this exercise was about like looking at data and deciding like what story is this data telling us? What's the information? What's the point of the data?
Yes, data storytelling is it's one of the skills that I think is important for good data scientists to have. It's one thing to be able to look at numbers like as a statistician and be able to read those numbers and take some meaning from them, but to change that into something that the general public can understand is where the data scientist comes into play often. A lot of the charts you'll see on the news, those maps that we've all seen with the bubbles for COVID-19, the maps, even the maps that are involved in election progress, things like that. I didn't know this until I started learning how to make them, but they're called choropleth maps, and they go all the way down to the county level. Some people have been able to experience those with the previous election, that you could zoom in on the state and see all the different counties, what color they would change, and which you'd see this particular election, you see a whole lot of red, and then like by the inner cities, you see these little spots of blue. Um, and I won't say luckily or unluckily because I don't want to sway anyone's opinions here, but it just so happens that those little spots of blue, even though it looked like a whole lot less in area, represented a larger part of the population. So, that data, the data that where would be able to extract from a data set like election results would show not just count how many counties voted one way or the other, but also be able to give us the population of those counties. And, you could weigh that county's amount of votes toward the overall electoral votes that the state casts. I don't know why I'm talking about elections. That has nothing to do with what we're going to talk about today, but just one example of how, you're able to reap the benefits of a good data scientist's hard work was, tracking election results over this past 2020 election. So
And that's why it's so important about data being collected and who's collecting it. And,
right.
when the censuses comes around, participate in the census so your voice is heard.
Yes, these are very, very important things. I thought I was going to get involved with collecting the census this year, and I was super excited about that. I got a keychain and everything that they brought me in, did my fingerprints, but I don't know what happened. I guess COVID had something to do with it, but they had to stop some things. They didn't. I don't know. They maybe they shut it down a little early, so I never did work for them. But maybe next time. I won't say next year because I don't think they do it every year. But next time I'll try because it's a good way to contribute. It's very important though. Census information does help determine how many representatives each county has. It helps determine how many representatives every state gets in the House of Representatives. You know, so those things can help in getting your political views through. You know,
And those are the guys who vote for laws and policies. So
right. People like to think their one vote doesn't count, but you know, when it's pulled in with everybody else's, even if it's not a vote, even if it's just you saying that you live there, it does help. It does help. It does actually contribute toward our system, which is maybe flawed, but we won't get into all that. All right, I'm going to share my screen, and we'll jump right in. Let me blow this bigger. All right, this is a lot of words. We can skip over this part. This is just some installation. I'll quickly show you what this looks like. I didn't know this was here. Oh, no, I won't. Okay, editors that we don't have, edit that part out. I will not show you the data set anymore. I guess it's no longer there, but I luckily still have it stored in my GitHub, I believe. So this maybe still will work. Maybe not. It looks like it has. So we're in luck. I was able to get the mobility data from no. Well, I'll go there. Google mobility data, boom. This exists. First off, this is another thing. You can get census, neighborhood, and demographics data. This is not where I wanted to be. Oh, that was an ad. This is what I was looking for. All right, so I found this was equal parts scary and exciting when I first found it, but I found out that there's global mobility reports now, especially because of, you know, the advent of COVID-19. Things like this have become available to the public, where you can get a regional CSV file. I guess we don't need to look at it right now like that.
question,
Yes,
how
ma'am.
are they tracking mobility?
That's a very good question. Everyone that has a phone and your Google account is logged in on that phone, it says right here, you know, you can visit your privacy policy, and they'll keep your data private, safe, and secure. You are anonymous. You're anonymous in their database, but their database does know where your phone goes. It knows everywhere you go. It knows when, as long as your phone's on, it doesn't matter if you're using maps or not. It shows your movements. If you go into your Google location history on your phone, you can see everywhere you walked any given month, any given day. So if you need an alibi one day or whatever it is, you need to figure out where that cool place you went, you know, last year, that you saw something at the park. I mean, you can figure out, as long as you had your phone on you and you had the same Google account, you were logged in, it's there. Even if you weren't using maps at the time, your timeline. So history data is directly from the timeline. I won't show mine right now for privacy reasons and such, but this data does exist. It doesn't look like it's easy to get into as easy as it was before. Let me see. Let's search by Maryland. That's where I exist currently. And it's only allowing me to download the PDF, which is fine. We can look at the Maryland PDF really quick. The other way to get it is to get what's called a CSV file, which I'll discuss in just a few minutes. But what this does is it shows you retail and recreation compared to the baseline means, here, let me blow this up, means on a normal day and a normal, you know, Sunday, January 24th, Sunday, March 7th, depending on what day it was, there'd be, let's say, a baseline of where everyone normally, how often people are normally in retail establishments and recreational facilities. Okay. Then this goes as far as to tell where the dips are. Like, okay, looks like around here, I can't really tell by this, but you know, where this dip is I guess it's probably beginning of February and end of January. Um, I'm assuming this is for 21. Okay. We can also look at different dates, but there was a really low, like a lot less people than usual. That's probably a weekend, so there's probably normally a lot more people at establishments and places of recreation like parks and things like that. Um, but it was way down because we're still doing mask mandates. People are still social distancing. What good reason would they have to be out at clubs um, and shopping malls and things? Luckily, a lot of the mask mandates have been lifted, and a lot of people are getting vaccinated. Those things are getting better, but you all hear enough about that in the news. So let's moving along. Pharmacies are not suffering nearly as bad as they used to be. They're only 10% down. They used to be a lot worse. There are times that they're 40, 80% down. I'm gonna show you how all this compares in my Maryland data. But the fact is, they have this data, and when I saw this, I'm like, wait, how do they? The first thing that made me think is, how do they know where everybody is and what everybody's doing? And the answer is they don't know everybody's information, but they do have a sample size of large enough of Android users that they can kind of estimate the rest, fill in the blanks with the rest. Um, that's also how they are able to be so accurate with travel times and traffic, knowing where the traffic's super heavy. It's because a lot of people are using their phones to navigate. And even the people that aren't using their phones to navigate, they know you can't run 75 miles an hour. So they know you're in a car, and if you're in a car between this point and this point, and there's a slowdown in one area for everybody that happens to be in a car that between those points, that's chances are it's a congested area for traffic. So the things that we all experience and enjoy are the rewards that are reaped from busy data scientists hacking away in the background and making use of people's data. So it's like it's important people like it's important as it is for people sometimes to try to preserve their privacy. Just understand that this data is not attached to any name. I mean, you know, and it would take a single person for every person that exists for anyone to be focused in on, and for them to figure out where you live and sleep every night. I don't think any of us are that important. I think they're really just taking this data and aggregating it into a pool of data that they can use to make good predictions, like how long is it going to take to travel cross country? How long is the trip to work going to be tomorrow morning, or should you avoid the normal path, and we'll tell you to go around this way because of heavy traffic. So
Yeah, I'm all for like conspiracy theories, but I use Google Maps for everything.
yeah,
I don't know
yeah,
where anything is. I was like, I gotta put out I could be
you
there like
know,
I've gone there like 5 times. I still do my Google Maps together. I'm the worst.
yeah. I mean, it's like it's a balance. It's like, it's like, oh, I want to be off the grid, but do I really want to remember everyone's phone number again? Never. Am I much enjoying, like, if I miss my turn, that it just tells me I don't have to figure out how to turn all the way around? I can just take this other one and get me right back on track.
Yeah.
100%. Yeah.
Listen, I remember MapQuest days, all right? Like
Yeah.
map and you have to look at the directions, read it.
Right. Where you hope somebody has a printer, or you got to go to the library and print it out just to make
Yeah.
sure you can get there. Because that was
I'm
still
very
high tech, boy. That was great. You didn't have to stop at the payphone and call when you got lost. Remember having to go to the gas station, and the third gas station you'd finally buy the map because you just couldn't deal with it anymore. Golly, we used to waste so much time. People in like 100 years are maybe going to see this and be like, they did what? They had to buy a map at a gas station? What's a gas station?
Oh, yeah. I don't think kids
Okay.
even know what maps look like an actual physical map anymore.
Imagine trying to give a kid a map and having him fold it nowadays. Good Lord. I couldn't even fold maps coming up. Like that was such a, like, gosh. All right, we're gonna jump right in. I said that a couple minutes ago, but this time I mean it. So first thing we have to go through is importing some things. We're gonna all code here is gonna be shown in Python. I don't expect anyone to really fully grasp everything that happens in this video. But, you know, feel free to ask questions in the comments. If you do learn anything, I'm also going to post a link for mine, and hopefully if I can get Sidani to make one, or buy me a coffee link. You know, if you get any value out of this, we don't have any way for you to donate to the channel or anything like that set up. So we do have buy me a coffee. It's a little, you know, quick little way to tip if you decide you'd like to. But anyway, back at it. Import matplotlib as pyplot. Matplotlib is a library that is mainly for, you know, plotting things, and it's a math library for plotting things. Seaborn's another plotting library. NumPy, which I used to love to call NumPy because that's the first thing I always called it, but I didn't realize that it means like numbers in Python or something along those lines. It's like a math library. There's a lot of functions in these libraries that we'll be using later on that, you know, so we'll need to import these libraries so that I don't have to write out all this code from scratch for the, you know, some of the things we'll be using. So anytime I report to SNS or refer to SNS in the code, that stands for Samuel something Seaborn, which is a guy from, I don't know. I guess the guy was a fan of that show. If you know what I'm talking about, you know what I'm talking about. But I don't even know what I'm talking about. I just know that, like, there's a popular show. It might be like, I won't even guess. It might be NCIS or something along those lines. But there's a character, and that's why Seaborn is SNS. That's the only reason. NumPy because NP. I don't know why this pyplot as pi is there, but, you know, I'm sure I used it. Pandas is PD. Pandas is a great library for handling data, for taking data frames or CSV files, which if I showed you what a CSV file looked like, let's see if I can pull one. Actually, this is a good one because this is in my GitHub, so, or it's in somebody's GitHub, so it should still exist. Let me move this out of the way. Okay. This is a comma separated value file. That's what CSV stands for, comma separated values. So you have columns, date, county, state. This is actually a super clean one, by the way. Normally it's just like, you know, right after here, there'd be another comma and then just the next line. So it'd just be a text blob. But this one's actually pretty good. It's a good one for explanation. So you've got date, and then you've got date right here, you know, comma separated, and then it goes into county, state. FIPS code is similar to a zip code, but even more specific. Cases and deaths. This was specifically for, I think, I'm not sure why I had this one. It says New York Times COVID-19 data. I think this is a nationwide one that I was looking through to try to figure out state by state how many cases and deaths there were. There just wasn't enough data collected yet. As you can see, this is like, it's like 3 cases, 0 deaths, you know, in San Francisco. So this was obviously way too early, and, you know, that this was posted for me to get any value out of this. But I just want to give you an example of what CSV looks like in the raw format. Not as important as what it will look like when we are done with it. So what Pandas does is takes all that and will put it into a clean setup like this. So you've got date, county, state, FIPS, cases, and deaths. All right, and these are the different counties. This is the state. This is a very small sample. If I change this sample to 10, run it, it'll give me 10 different ones. It'll take its time, and then it will give me 10 different ones. There we go. Because I used sample. Now, if I did head or actually put dot head here, it would give me the top 5 or top 10. Top 5 is default, but if I put 10 afterwards, it will give me the top 10. I'm not probably going to keep running this cell because each time I do, it wants to reload the whole data set. So that's why it's taking a couple seconds. But you get it. So now the indexes start at 0, go from 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't show you before, but what's this called? DF? No, it's called US counties. Much quicker if we don't reload the data set every time. You'll see before though, the index is here with these large numbers because there are lots and lots of counties in the United States of America. Apparently there are over 99 or 994,000. I had no idea. Maybe they're not. Maybe actually that's not true. But there's so many. There's ones that are different by date. So I could do a lot of different things here with pandas. I could narrow this down to where the county equals carbon, and it will show me all of Montana's different dates and their cases and deaths. I guess that also is something I could have pointed out about the other data set, is that it's super long and would take absolutely forever for any person, computer, or anything to read through all of these, and they're not indexed. I could just, there's just, I don't know how I can explain it except to keep showing you screens of it, but it just goes on and on and on and on and on. And as I get closer to the bottom, see how this thing is jumping up? It's just still filling in more and more and more space. So it's like, it goes forever. So no human could sit here and filter through all this and do anything meaningful with it as quickly as we can with fancy computers. So that's what we're doing. We take information. I've got something. This DF mob is just a variable name that I came up with for DataFrame mobility. And I read in, hopefully this still exists, this mobility report, global data mobility report. Okay. I look at the info of that mobility data frame, and I find that I have 14 different columns. These are all the column names. Okay. And then I have these percent change from baselines. Okay. For retail and recreation, grocery, pharmacy, parks, transit stations, workplaces, and residential. So yes, they know when you're at home, they know when you're at work, they know where you're in transit stations. Not to freak anybody out here, but there are ways of them knowing without actually knowing who you are or what you do for a living or anything. If you're at a place 12 hours out of the day, and your phone doesn't move anywhere, you're probably at home. You know what I mean? If you're at a place 6 to 8 hours and your phone does bounce around a little bit, you're probably at work. So they take data and they're able to extrapolate, okay, they're at work. This is a business. Nobody lives at Clorox factory. So, they know when there's a bunch of people there, they're at work. So yes, anyway, though, Maryland counties, there's somebody out there like, you're just a shill for Google and we know you're spying on us. All right, Maryland counties. So I've made something called a separate data frame called Maryland counties. And what I've done is taken the US counties data frame. Okay. And I've narrowed it down to where US counties column state equals Maryland. So that just means take everything out of US counties where US county state column is equal to Maryland. Basically, this is what you get. You get, I did a little quick sample of that. Matter of fact, let me just, I'll do it, instead of doing it again, I'll just do Maryland counties .sample. No, not .sample. Let's just look at it. Let's just say boom. Give me the whole thing. This starts off at the very beginning. This is called the head. This is called the tail. The reason why the indexes start at 555 is because this came from originally a data set from the entire US. So we didn't get to Maryland until about 550, or we didn't get to Montgomery at least. Whichever this first entry is from Maryland didn't happen until index 555. But what we've got here is a whole lot of, we've got 8,895 rows times 6 columns of just Maryland. state, FIPS codes, cases, and deaths. Okay, as it gets later in the data set, we're getting more and more deaths. Apparently, Washington County didn't do so well by 3.9. By the way, I should also mention this data goes back to oh, this is new. Okay, it updated itself. I was like, wait a minute, I thought this was all back from August. But so, okay, interesting, because this is not going to match my my article that I wrote. I'm actually able to explore this data again because I've updated now all the new data, all the new mobility data. So this is fun for me too. So this will be an experiment. So DF mobility, I'm going to make a new data frame of DF mobility. I'm just kind of writing back over the same one I already had. And this is just shortening feature names on the main data set of the for the graphs. So I don't want to say retail and recreation percent from change from baseline as like a point, as something on my graph. I can just have that say retail and rec. You know, I can just have it say grocery and pharmacy. I can have it say parks, transit, work, and home. I'm good with that. And you'll see why later, because it'd be ugly. Trust me. Okay, and then now DF mobility date. What did I do here? I'm changing all the dates to a DateTime standard. There's something called DateTime. That is a, oh cool, here, look at that. So it's a module straight out of pandas. Or pandas is the module. I don't know if DateTime will be shown. It does give us parameters. This is awesome for a podcast. Okay, so not only does this tell you what you need, what you can put in, the arguments that you can put in, like string equals raise. I'm not sure what that does. You can put year first instead. If you're in a different, country, sometimes they have their DateTime formats different. So you might want to let it know to look at it differently. As far as UTC, I think you might be able to convert things to UTC standard time, which is the, that's the right on the Greenwich mean. That's the earliest new date. So they celebrate New Year's first. But yeah, this is a bunch of stuff you probably don't need to know. But what it does also show you are some parameters that you can enter. This is also, I should mention, we're using Google Collab, which is
the Google plug right there.
Yeah, another Google plug, right? Google does a lot of free things for you. Just enjoy it and shut your mouth. But yeah, so it's pretty handy. It's a pretty handy tool. As you can see, it helps you as you're typing. Like it'll give you all the documentation right there on the spot. I don't even think it used to do this when we were using it, to tell you the truth. I was mad that Jupyter Notebooks was better at this type of thing. But this is just a way that you can test things in code without writing out an entire program. You can do some data manipulation. You can get a data set all structured in the way that you want it. Like all these changes I'm making, now when I'm done with the changes, I can save that data set and I can refer back to it in a program, in an online application. I can go to just my curated data set with everything that's, everything in the way that I like it, and then report back the information on my charts and things the way that I want it to look without having to do all that work over again. But so some things like that are handy to do in notebooks. As you get farther into data science, they consider it to be an important thing to do to get used to working locally and in IDEs, which I don't know what that stands for, but they are text editors for programming. They're compilers. I'm sure I could look it up really quick, but yeah, I'm not going to pretend I know. So here we are, some shortening the feature names we've done. The DateTime standard is important because then I can just, I can pull things out of it instead of just having a column called dates. And this is the DateTime data type. I don't know why it's called that, but it is. I can say, I can pull out month, or I can pull out day, out of a DateTime object. If it's just a number separated by slashes, which is really just a string, it just sees it as a word and it doesn't know what day of the week that that is, and anything like that. So moving on. DF Mobus. I had some fun variable names back in the day. Okay, this is DataFrame, Mobility US, and country where the country region code was US. Then from DF Mobility Maryland, I took it out where just just the subregion 1 was Maryland, and then I dropped columns. I dropped some columns I didn't need. ISO 3166-2 code. You probably don't know what that is. I don't either. That's why I didn't need it. So I dropped it. Print. I printed out the shape. Okay, that's where this prints the shape. This tells me now I only have 14 columns because I dropped one, and I have 9,528 observations or rows. Different data points also could be said. So then I renamed column subregion 2 to just be called Maryland counties, because I knew subregion 1 more by state, subregion 2 was by counties. I could tell that by looking at these things. Wait, that's not even the right data set, but that's okay. I won't bring it up right now. Just trust me. All right, and so going on, I go on to values trying to set on a copy of the slice of data frame. I don't know what any of that was. Oh, here we are. So we've got subregion 1. Subregion was the whole country. And then now we've got Maryland counties instead of subregion 2. The reason why I didn't go as far as to rename the other ones is because I don't use them in my charts. So when I chart this stuff, I wanted to use a Maryland counties as my key, so I could have a different color for each one. You'll see what this looks like in a few minutes, and prepare your eyes for greatness. Maryland counties, U.S. counties equals U.S. counties, state equals Maryland. Okay, so I made even a smaller one called Maryland counties. So we're down to just Maryland, and then we've got it separated into counties. This was a whole lot of data wrangling I had to do to get down from a global data set to just Maryland, to just the counties. Just give me the part that I want to look at so I can present a story to tell. And I'm going to try to speed through some of this stuff. If you guys have any questions, I'll leave a link to this in my GitHub as well. If you guys want to look at it, play with it on your own, you can make your own copy in your own Google Colab if you want to get crazy with it. We have earlier dates in the original data set, so we will have to filter out some to compare. All right, this happens because I merged two data sets together. One of them had deaths and cases. The other one only had mobility data. So I wanted both. I didn't want to just know where everybody was moving and where they're going. I wanted to know, like whether or not, originally when I started this project, I wanted to show whether or not cutting people's mobility down and stopping them from moving around and doing the things that they were doing was actually changing the numbers, whether it was helping or not, whether the shutdowns were actually helping. I later on had to abandon that experiment only because there was no control group. There was nowhere where mobility was not changed at all. And I'll say that confidently because I looked at it. I even found out that Sweden didn't have government shutdown. So those of you that are thinking, Sweden, nobody's thinking that. But anyway, Sweden did not have government mandates to shut down. But if I looked at their mobility data, they still were smart enough to stay home and not go to work and not go to the same place. Their mobility data reflected, they listened to their scientists. They didn't need the government to tell them that they weren't allowed to go to work or school or things like that. So, good job, Sweden, but that didn't help my experiment. So Google location data is compiled to display a percentage of change from the baseline on the COVID-19 community mobility report page found here. Okay, I won't click on that because I already had to search it out and find it earlier. The 0% change is to what I will be referring when I say things look like the norm, usual, day-to-day, or normal. All right. I guess these were some things that I also had, because I wrote an article about this. I'll also link that in the description. I would probably take up too much time to walk you through the article. I don't know, we'll see. I'll let Sedani go, and if we have time, maybe I'll bring up my article too. But here we go. Here's the big grand finale of this piece probably for now. Lots and lots and lots of dots. Okay. Maryland counties are here. So Allegheny, Anne Arundel, Baltimore, Baltimore City. This is Baltimore City, Baltimore County, all the way down to Wicomico and Worcester. Those W counties, I don't know what it was, but those pink counties were some outliers in some things. You can see that they were still going to work more and groceries and pharmacies more. I don't know if they're just more rural areas where they weren't in high concentration. But when I originally did this data set, that was different. I think also though, this will probably, this still does cut things down to certain dates. So this might not be up to date. I know that when I originally did this, I had to limit it to certain dates because I didn't have certain dates in my deaths and cases column. I'll have to look. Actually, I'm just going to do it now. Live. This is what happens when you go live. All right. How much? That should do it. Yep. There we go. How much? Boom, bat. So this is the Medium article. Sorry, we're closed. This is my handy photoshopping work. I totally jacked that background photo from something online, but it wasn't copyrighted, I don't think. Okay, no, the charts have changed. Looking at this compared to the other, because there was big old clusters up here in the grocery farm and work area for the pink. So this is up to date. Oh, wrong one again. So it is different. So this includes all the way up from then till now. As we can tell from these charts, it's okay. Let's take a break for a second. Okay, that's lots of dots. I know. As a data scientist, exploratory data analysis is my first step in finding out which data would be important to compare. Data, by the way, is plural. Each dot represents the percentage of change from the baseline of the cell phone toting public, basically everyone's movements in a particular day during the pandemic response in Maryland. This data represents the mobility from March 5th, 2020, when the first cases of COVID-19 were reported in Maryland, but before any response was mandated by our local government. On March 12th, and it goes on to talk about Governor Larry Hogan's dramatic announcement issuing an order banning all large gatherings of people and activating the National Guard. The same day, all public schools in the state announcing a temporary close for 2 weeks. Remember that? To the 14th of June, 2020. 2 weeks. It's been a year almost. Oh, wow. The days. Wow. I see. So I see in the above graph that the percentage of change from the baseline was most positively correlated in time spent at pharmacies and grocery stores as compared to time spent in retail and recreational activities. If one was lower, so was the other, and vice versa. Let's see if that still exists, because I was referring to this graph. We're looking at, we said we were talking about grocery, pharmacy. Okay. As compared to retail or retail and rec. So yeah, like because of the way that these dots are almost all kind of in a straight line with each other, they're very clustered around like a very, and I'll break that down a little bit better a little later in the journey here. So yeah, if one was lower, the other was, and vice versa. On the other hand, the amount of time spent at work was negatively correlated with the amount of time spent at home. Seems legit. I'm laughing at my own writing here. Without any personal experience, you can infer those things may happen in a time of panic. More time at home and less time at place to work, less spending in retail, and less traveling to grocery stores. And I guess the thanks Instacart is so I could throw a link in my article, but thanks Instacart. You definitely have been there for us all. So in next chart, we're going to just zoom in a little closer. I'll show you only the time spent at work as compared to the time spent at home. So here's some code for it. This is when I use SNS, that's Seaborn's charting library. Let me blow this up a little just before we jump right into the chart. The x-axis is the DF Mobility Maryland. column work. The y-axis is the mobility Maryland column home. And the hue, which is the different colors, are the counties, okay? So that's the same thing going on up here. I hate going back and forth, but I'm going to do this one time. I want to show you a little bit more about what's going on here. This is everything in the data set compared to everything else. So when you see one of these, that just means it's comparing itself to itself. So this is home and that's home. It can't give you one of the scatter plots. So instead, it just gives you a histogram representing the different county, and over a period of time. Now, when I break down to just one of these, let's say I want to see work versus home. So I see home, I see work. This is what that looks like. Okay. So we'll go back down to home versus work, and that's what it looks like. Now, if you say, well, hold on, that was backwards. Actually, you won't say that because it isn't. There's also another one. There's one that's work versus home up top in the corner. So, okay, this is a little bit closer. When we zoom in, there's the clear negative correlation is shown, by the blue line. Who can argue with the blue line? It just shows that, and this is the line that represents the least distant from every point. So if you had to try to draw something that's, closest to the farthest points, even like the outliers, they still count. So this is the middle level. This one's just kind of blown up, like expanded a little bit to show some clarity, because otherwise you just get this. It just looks like they're all sitting on top of each other. It's smashed. But it's pretty much showing you the same thing. Let me zoom out a little bit. On the left is all those data points, but spread out for better visibility. So here I can see that not only were most of the data points below the baseline for work, but above the baseline for home. Also, the negative correlation is very apparent, as shown by the blue line. So when you say, here's the zero, by the way, this is a zero. So this is your normal, everybody's going to work, spending time at home, spending time at work, is right around here. This is what was happening. Like, this is where we all ended up being more at home, which is higher on the home side, and, less and less at work. This is, work goes into the negative, home goes higher and higher. And if you want to know the cut, oh yeah, you can see the numbers over here for home. So, it's a chart that you're probably not going to see on the news, because it does have a lot of data involved. It doesn't really make sense intuitively to look at, but it does tell a story, and if you're able to explain it and show people what's going on. The zero is the baseline. So this is the zero line going on the vertical or the horizontal zero line. And this is the zero line on the horizontal axis or the vertical zero line. So from here and here, you see, like, there's not a whole lot going on in the positive side of things as far as work goes. And there's not a whole lot of going on in the negative as far as home goes. I'm beating this into the ground, but just wanted to show you this is kind of how plotting data proves a point. It tells, and then even if I didn't know that was happening, if I was trying to search something, another experimental thing out, and all I had was a whole collection of data points given to me by some, I don't know, radio telescope, pointing out all these things in Earth. And I bring that up as kind of a plug for my next project that I'll be showing you someday. But yeah, some things are just going to give us data. Computers are good at that. They're giving it like, we've examined and this is what you got. Brrr, numbers and charts. And you're just like, okay, what human has any idea what any of this is? All right, back on track. So yes, they're below and above. This is a graph showing time spent at retail stores and recreational venues as compared to the baseline. Again, the baseline is here, 0, 0. The cluster gets to be lower and lower. But there are, any one of these are dates in any order, by the way. They're just, each one of the pink dots is a point for one of these 3 counties, because there got to be enough counties that you couldn't really distinguish too well which one was which when it got to the pink for some reason. But the point was only for some reason, it seemed like the farther it was in the alphabet, the more that they just did whatever. They were still doing retail and rec at the time. But one thing I did notice about this was it didn't really seem to matter whether or not they were open. I know that's kind of extrapolating. That's just like making an assumption. But what I'm looking at is grocery stores and pharmacies pretty much stayed open. Retail stores and recreational facilities didn't, but they both suffered the same or about the same. There's still just a very thin, like perfect line, and that's why I say like there's a correlation going that way. If I one more time, I'll jump back up here. Sometimes you just see stuff's all over the place. There's no clear like this being the 0. I mean, there's still a big cluster above. People were doing more time in parks. That's cool. But there was no, I couldn't take this chart and be like, I know exactly what to say about this, but I'm able to tell from something that's tightly grouped like that, that there's some correlation going on. So I think that's just about all I have as far as this project goes. This one also does a little zoom in, and it explains in search of the perfect jitter. This was just my working on trying to make this look as as good as I could. So what I named it that, but you don't see me do. Oh, maybe you do see me doing it. Some quick data set exploration, that's later on, but I was just I just kept changing this jitter. So let's say I change it to 100 and run it again. It spreads it weird, like in a different way. If I make it 10, I don't know, I don't need to do that to make it 10. It makes it a lot closer to the original. So I was like, how can I, make this thing look great? I want it to be as close to looking like the original data, but also be a presentable chart. So that's some things that we do. We will ignore that. That doesn't exist. So yeah, I think that's the end of this project. I've taken up enough of your time, and I think the only other thing that I have to say is, I also have this posted on a Medium article. This one was not published by any publisher. I tried Towards Data Science in this, but shame on you, Towards Data Science. I've got talent. So in conclusion, I found things. Firstly, that's supposed to be funny. Firstly, I found that the less time people spent at work during this pandemic, the more time they spent at home. The most this has taught me is that Google location data is quite accurate, as I've been witness to these changes firsthand. This is a slightly less exciting realization than what else I found. This one's in bold. I also discovered the amount of time people have spent traveling to brick and mortar locations to be independent of whether they remained open or not. That is not necessarily true, I guess. Maryland pharmacies and grocery stores remained open for the most part, but still suffered a decrease in traffic directly correlated to that of retail shops and recreational venues, which were all closed. I'm thinking though, no, I guess that is true, because I was thinking
at the time when it first happened, everybody stopped going everywhere.
Yeah. There was a time, and a lot of this was in the beginning months. Yeah, this only was through August. I think of so this started off, of course, around the beginning, before the mandates until August. So we're talking about between March and August was the original time of writing this. So yeah, people just shut down for a minute, and it really did affect everywhere pretty equally. That's it.
Yeah. Sweet.
Got 100 claps. I didn't even notice. All right, cool. I will stop my share at this point and pass it to you, Sidani.
How many minutes are we in right now?
You know what? I don't know. That might have been an entire hour. I do not know. Do you think you want to wait?
Yeah, I mean, maybe you could just make our next podcast where we kind of dive into my first project.
Absolutely.
Hopefully, I'm as detailed and I as well as Timothy.
If not, I'm sure I could always fill in the blanks. Go ahead.
The thing our both projects do have in common is that we both did tackle a current event that was taking place during that time. So I think that would be cool for us to make that correlation.
Yeah, give them a little teaser though. Tell them what yours is about. Maybe they'll be sure to tune in.
Yes, please tune in to our next podcast. So I did my project, and I just had to share my Medium article really quickly. So I live in New York, and during this time, the unfortunate, tragic murder of George Floyd took place, and there's protests everywhere, and I started to think about like being a New Yorker, what that looks like in New York. And so I went and I took out some data about crime in New York and also about citizens' complaints against the NYPD. And I wanted to kind of look at that and contrast it and see if it correlated in any way to what was happening on a national scale in our country. So
All
I
right.
think next time we will get into that.
Tune in next time on Spill the
Thank
Data.
you.
All right, thanks. Again, I'm Timothy Aiken, and this is my lovely assistant for this podcast. I'll be the assistant next time, I promise. You can even call me lovely. I won't take it offensively. But this is Donnie Daly, and again, this has been Spill the Data. Thanks.
Thanks for joining us, guys.